Alright, so we are going to start section 11.1. In this section, we're going to revisit the topic we talked about in the intro about solving quadratic equations using the square root method. Again, you can't use this method unless there is no middle term. What I mean by that, like in this first equation, there's a k squared, but there's no k, right? Then we can use the square root method. Here there's a v squared, but there's no v, so we could use the square root method. Here there's an n squared, but no n, so we could use the square root method. So that trend will work to determine whether or not you can use the square root method to solve a quadratic equation. Now I've circled these, the ones I'm going to do, 1, 2, 4, 6, 7, and 8. So I've picked those out. Those are the examples I'm going to do. What I suggest you do is do the others for practice. On the next page of the notes, you will notice all the solutions are here for you. So as you do the others for practice, you can check your work to see if you're on the right track. But I will do a few examples. So first one, to use the square root method, there's a k squared, there's no k, I can use the square root method. I'm going to subtract the 6 from both sides, right? So then I get k squared equals 0. Normally we would do k is equal then to plus or minus the square root of 0. But 0 is kind of special, and that's why I threw this one in here to show you this special case. Negative 0 and positive 0 are the same thing, aren't they? So this is the only case where we don't have to do a plus or minus. So we could do it, so we could say k is equal to plus or minus the square root of 0, but square root of 0 is 0, and adding or subtracting 0 results in the same thing. So k is just equal to 0, which means your solution set is just the single solution 0. That's the only time really when we're going to get one solution is when you have a 0 involved. Alright, next one, number 2. We have a v squared but no v. That means we can use the square root method. Get all the numbers on one side, so we divide by 25. And so we get v squared. Okay, v squared is equal to 1 over 25. That means v is equal to plus or minus the square root of 1 over 25. We can take the square root of both top and bottom. So square root of 1 is 1, square root of 25 is 5, and so we get plus or minus 1/5. Now you could put the set symbols around that, and so you could write it like that. I think MyLab has a plus or minus option for you, or you could write it like this, where we have your two solutions, negative 1/5, positive 1/5. Either one of those would be okay, I believe. So check that on MyLab. Make sure you do the homework so you can test it out before you get into the final exam. Alright, let's do number 4. I circled that one also. So we're going to add 2 to both sides, right? So we have x squared is equal to 19. Which means x is equal to plus or minus the square root of 19. Now there's nothing we can do with that, right? 19 doesn't have any perfect square factors, so this is a case where we just have our solutions, negative square root of 19 and positive square root of 19. Again, I think you can use the plus or minus if you want to instead of writing it this way, but you might check that out. Alright, so number 6 is the next one. That one was easy, wasn't it? We're going to, let's see, we have an r squared but no r, so we can use the square root method. We're going to add 5 first, so 9r squared equals 607 plus 5 is 612, right? It's equals 612. And so then we get r squared is equal to, we divide by 9, we get 612 over 9. So we're going to take the square root, and don't forget to do the plus or minus, which means r is equal to plus or minus the square root of 612 over 9, right? Alright, so we know the square root of 9 is 3. Square root of 612, let's see, does 612 have any perfect square factors? I'm going to start looking in, so I'm using my calculator, I'm going to start dividing 612 by some perfect squares. So let's see, 612 divided by 4. 4 goes into it, but maybe there's a bigger one, some other multiples of 4, like 16, right? That's a good one to check. So let's take 612 divided by 16. That doesn't go in there. What are some other multiples of 4 that are perfect squares, like 36, right? So let's try 612 divided by 36. Ah, that works. It's 17 times, and 17 is not a perfect square. So I think that's going to work out well for us. So let's separate this, plus or minus. So on the top, we have the square root of, I said 36, right? So 36, which is a perfect square, times the square root of 17. And then we're going to divide by square root of 9, which is 3, right? So this is multiply, not subtract there. So now we can write square root of 36 as 6, right? So this is plus r equals plus or minus 6 square root of 17 over 3. And you might think, well, I did everything great. That should be my answer. But can this be reduced? It can, right? Because 3 goes into 6 twice. So we get 2 square root of 17. And so let's see. Let's clean up my answer a little bit. I'll write it out here to the left. R is equal to plus or minus 2 square root of 17. All right. So those are your two answers in a simplified form. And set symbols, I have negative 2 square root of 17 and positive 2 square root of 17. All right, so maybe I should put some circles around these. There we go. And this one. All right, we've done 4 out of 6. We have 2 left. I try to give a variety of examples here, some where you have to simplify quite a bit like we did here. But let's look at this one. This one, let's see. It has an n squared, but there's no n, which means we can use the square root method. I'm going to add 10 to both sides. And we get what? Negative 5n squared equals negative 320. Then we divide by negative 5. Let's see. 320 divided by 5, what is that? 320 divided by 5. That's 64. So we have n squared equals 64. Negative 320 divided by negative 5 gives us our positive 64. This one's an easy one, right? Because n then would be equal to plus or minus the square root of 64. But what is the square root of 64? It's 8, right? So n is plus or minus 8. And so your two solutions, I'll have my solution set. We have negative 8 and 8. That would be your answer. Again, MyLab will give you these set symbols. All you have to do is a comma-separated list in between there. All right, I saved the best for last. Maybe it's a doozy, I don't know. We'll see. I'm not sure. I think it's a little hard to simplify, but not hard to solve. So let's subtract the 7. We get 5a squared equals negative 67. Divide by 5, we get a squared is negative 67 over 5. Now, if you were asked for the real solutions, because we have a square equal to a negative, you'd say that's not possible with real numbers. There are no real solutions. And that's true. But you may be asked to give all solutions. In that case, we have to introduce that little guy I, right? So we can still do this. We can solve it. We just won't get real solutions. So we're going to take the plus or minus the square root, right? So a is equal to plus or minus. And I'm going to split this up into, well, we don't have to, I guess. Square root of negative 67 over the square root of 5, right? Now I could take the square root of the whole fraction, but we can do that as well. So there are a few problems with this answer. First of all, there's a negative underneath the radical, which means we need to pull an I out, right? Second of all, we have a radical in the denominator, which is not a good thing, okay? Mathematicians, in standard practice, to not have radicals in the denominator if it can be avoided. So to avoid the radical in the denominator, we do a little simple trick. We multiply both top and bottom by the denominator square root of 5. That will remove the radical from the denominator. What we're really doing is multiplying by square root of 5 over square root of 5, which is 1. So we're not changing the value of the answer because we're multiplying by 1. But we'll change what it looks like, and it'll help us get rid of the radical in the denominator. So what's this look like now? A equals, let's see, square root of 5 times square root of 67. What's 5 times 67? 5 times 67. It's 335. So we get the square root of negative 355 over square root of 5 times square root of 5 is just 5. So you can see how that removed the radical from the denominator. Now the only other issue we have, oh wait, we forgot our plus or minus. Plus or minus. The only other issue we have is we have a square root of a negative. If you have a square root of a negative, you can pull an I out and make it the square root of a positive. So A is equal to I plus or minus I times the square root of 355 all over 5. Those are your two solutions then. Okay. And if you want to use set notation, I think MyLab will let you just put the plus or minus in, but if you can't find the plus or minus, you should be able to find it in the toolpad. But you could split it up into two, and maybe I'll do that down here. So we have negative I square root of 355 over 5, and positive I square root of 355 over 5. All right, and that would be our solutions. So that's it for the square root method. Again, I suggest you do some of these others for practice and see if you can get these same answers that are on the next page that you can look at. And we have one section left to cover 11.3, and we're done for the course actually.